Today we're back with another very interesting topic that we often get questions about: safety analysis. What is the purpose of safety analysis?
In functional safety, there are two ways.
Here we have listed 4 different steps that are involved in FTA.
Can there ever be a case where you have a bit of a conflict between the FMEA you did and the FTA you did, or is it only theoretical? Hello and welcome back to Matrix Tech Talk. This is Hassan Akram, your host of the Autonomous Vehicle Safety and Security podcast. Today we're back with another very interesting topic that we often get questions about: safety analysis. So without further ado, let's begin. Today we have 2 Matrician guests, Praveen Suvarna, our safety expert. Praveen, welcome to Matrix Tech Talk.
Thank you. Nice to be here.
We also have Phalgun, who is known as the car hacker from Matrix. Phalgun, welcome to Matrix Tech Talk.
Thank you, Hassan. It's nice to be back here again.
My first question would be to Praveen. Praveen, why is safety analysis important? In other words, what is the purpose of safety analysis?
That's a good question. So to explain why do we need safety analysis, maybe I would like to take you a bit back into the very definition of functional safety. Because if we go and check the definition of functional safety, it says absence of the unreasonable risk caused by the malfunction in the E2E system. If the E2E system, there is any malfunction in the software or a system or a hardware, if that results into an hazard, what could be an hazard? It could be that, okay, there is no directional control. The driver is not able to control the speed of the vehicle, maybe the brake failure, for example. Or maybe they are not able to steer well, steering column is locked. This could lead to an hazard. And if there is an unreasonable risk due to that, then that should be avoided. There should be an absence of unreasonable risk. Now, what safety analysis will do is, this is a way in which we can identify, or we can try to figure out what could be the possible failures in the system. And we can already take some safety measure so that whenever we unfortunately get into that situation where there are some malfunctions in the system, our safety measures will already kick in, and it will provide the safety for the user or the driver. So I would say it is kind of a proactive approach wherein we can identify or anticipate what might go wrong in my product, and we can already implement some measures so that we can ensure the safety of the product.
Interesting. Praveen, you used several terms. One of them was unreasonable risk. What exactly do you mean by unreasonable risk?
Unreasonable risk in the sense, if at all I can give an example. For example, even in the high-end vehicle, whenever we get into the car and we wear a seatbelt, we don't really think that, okay, now I'm wearing a seatbelt, which is one of the safety measures. Now, even if I end up in an accident, unfortunately, nothing is going to happen to me. We are not thinking like that. We know that, okay, even with the seatbelt on, if I end up in an accident, there could still be some injuries, minor injuries. So what is unreasonable risk? Unreasonable risk is something which is not accepted by the society. Because we all know that I wear a seatbelt, unfortunately something goes wrong and there is an accident. Still, there would be some injuries or minor injuries or scratches, but it may not be as dangerous as life-threatening. Unreasonable risks are those which are socially not accepted.
When you say accident, nothing will happen, you mean minor bump? I mean, still, and even if you wear seatbelt, if it is a severe accident, then you may even die. So the seatbelt is not going to save you. You mean minor bump or that kind of an accident category?
Exactly. Yes. Yeah. So the very definition, or how do we perceive an unreasonable risk which is not accepted by the society, in a way to say. Yeah.
Very interesting. So with that, let's stick to the seatbelt example for a while. Yeah, so if the bump is minor, your seatbelt protects you from unnecessary avoidable risks. So this is what you're terming as unreasonable risk. So what will safety analysis tell us in such a scenario?
In such a scenario, when it comes to the safety analysis, we will be in a position whenever we develop a product. I mean, I use the general term as a product. It could be a system or a software or a ECU. Whenever we develop the product, it will give us an option to proactively anticipate what might go wrong in this product, and this will also put us in a position where we can identify the safety measures. When our product goes into this kind of malfunctioning mode, then we will also have the safety mechanism in place to lower the risk which is caused by this malfunctional behavior of the product. Because every malfunctional behavior will result in certain risk. We won't be in a position to completely avoid the malfunction because it is not 100% in our hand, but what is in our hand is to anticipate the malfunction which might happen in the system or the product, and to already have a safety mechanism in place so that when the malfunction occurs, we can still keep the risk level to the reasonable level so that there is no harm to the user or the driver.
So Phalgun, my question to you is, what are the safety analysis methods out there that we use, that are often used, and what are they?
Yes, this is a very interesting question. So we have a various number of safety analysis methods. So one of them is FMEA, failure mode effect analysis, where we try to perform how to identify different failures. Then there is DFA, dependent failure analysis. There is FTA, a fault tree analysis. So these are various different types of functional safety analysis methods.
Thank you. Then, without further ado, I will ask Praveen to show us the ways to do safety analysis and tell our audience a little bit detail about it.
To answer your question, I would use the flip chart. So if at all we have to divide the safety analysis method, then the one way is to the way it is conducted, the safety analysis method. So normally in functional safety, there are two ways. The one we call as inductive safety analysis, and the second one is deductive safety analysis. Now the question comes, what is inductive and what is deductive, or what are the differences? So if we talk about the inductive safety analysis, then it is normally a bottom-up approach, because whenever we start with the safety analysis, we know that there are various abstraction level. If you go from top to the bottom, then we normally start at the vehicle level, then we come to the item level, which is nothing but the collection of systems. Then we come to the system. From the system, we go to the lower level like software, hardware, and mechanical. Or we can also go from the other way around, which is a bottom-up approach, where we start with the lower level like software, hardware, mechanical. Then we go to the system, from there to the item or to the vehicle level. So inductive safety analysis method is a bottom-up approach, which means we come from the lower level to the higher level. And also what we try to do in an inductive safety analysis method is we start with the known causes, and using which we try to identify the possible effects. So what do I mean by that? What are known causes? For example, known causes could be something like we know what will go wrong. Using that, I will try to find out what will lead for this, which means what happens because of that this malfunction will occur, this failure will occur. So this is the bottom-up approach. And one example is FMEA, the failure modes and effects analysis. So this method actually belongs to the inductive safety analysis.
And why is it called inductive?
It is a method in which you know the causes in the lower level, and using the causes, we are trying to induce the phenomenon in the higher level, which means if at all I know the failure in the software level, looking at that, I'm going to induce in the system level to understand what it might lead to, what kind of failure it will lead in the system level.
All right, so this relationship, known causes to the possible effect, is actually from, since it's bottom up, from lower level to higher level. For example, it can go to unit level to software, software to system, system to vehicle.
Vehicle, yes.
All right, so the causes in the lower level, for example, system is known, and you try to identify the effect of it in the vehicle level.
Vehicle level.
Got it.
It is also the other way to see for a developer, because normally whenever in the functional safety project, if the project is really complex, then if there is a developer, he might be working on one or two software components in a bigger project, because sometimes people misunderstand or people underestimate how much they are contributing to the functional safety. But this is another approach wherein they can see if at all there is a failure even in the software component level or in the unit level, it can propagate all the way up to the vehicle level, and it may end up violating the safety goals at the vehicle level. So this is another way from the safety awareness side, how people or the engineers should see the way they contribute to the safety of the product. Phalgun already explained the various safety analysis methods like FMEA, FTA, DFA, etc. So FMEA is one of the methods which falls under inductive safety analysis, because it is normally a bottom-up approach, and also we follow the same sequence, like the known causes, and using which you try to identify the possible effects in the higher levels.
For our audience, what does FMEA stand for?
FMEA stands for failure modes and effects analysis. If at all I have to explain in a very simple term, then you identify the failure modes and you try to induce its effects in the higher levels, higher abstraction level. So in the deductive safety analysis, we know the known effects and we try to seek the possible causes, which means we try to understand what is causing this failure in the lower level, which means if at all I know the failure, or if I identify, or if I start with the failure in the system level, I try to go one level down and try and understand what is causing this failure in the system level. It could be coming from the software, hardware, or mechanical, any of the lower levels. To give an example, FTA is one example which falls under the deductive safety analysis method, where we follow the top-down approach, where we know the failures, we identify, we start with the failure in the higher level, and we try to deduce what is in the lower level causing this failure in the higher level.
So before we go to the next topic or next question, I really want you to hit the like button and share this video. That would mean a lot to us. Please hit the like button now. Coming back to our topic of discussion today, Praveen, thank you so much for explaining this. Now, my question to you would be, when to do which method? How does the standard prescribe or recommends or makes things mandatory?
If we look at ISO 26262 Part 4, which normally talks about the system level, there is a table which clearly describes which safety analysis methods are mandatory for which SL level. So if you talk about the inductive safety analysis method like FMEA, then it is mandatory for all the SL levels from SLA to SLD. However, the deductive safety analysis methods like FTA, which is only mandatory for SLC and SLD.
So for ASIL A and ASIL B, FTA is not necessary, but is it done in practice also for ASIL A and B?
With my experience, I have seen sometimes that safety experts will also combine both deductive and inductive safety analysis method even for SLB project. So that is not, as I said, which is not a mandatory even for a deductive to be done for SLB level, but it's on the understanding of the experts and the safety managers. If at all it brings value in their product development, then normally they can also opt for it.
Amazing. So if you're liking this video, if you're getting value from this video, I really want you to go and hit the like button, subscribe to the channel if you haven't. Now, coming back to the video, today we're going to also talk a little bit about the FMEA methodology, how to conduct an FMEA. So Praveen, how do you do an FMEA?
To talk about FMEA, which is really a complex safety analysis method, because even in FMEA, there are multiple variants to say, like you do the FMEA, then you do for hardware FMEDA, you also have qualitative FMEA, quantitative FMEA. However, if at all I have to explain the way to perform an FMEA in a very simple terminology in which everybody can understand, then normally I would divide it into 4 steps. The first step of performing an FMEA is coming up with the structure tree, which is a top-down approach. We have to identify what we are trying to analyze in the vehicle, item, system, and in the lower levels. So this will form a tree kind of a structure from top to down, in which abstraction level, what are we trying to analyze? What is our component? Then the second part, once we identify or once we design the structure tree, Then the second part is to come up with a function net, which is also once again a top-down approach, which means what functionality we are talking about. For example, we think of a system in the system level, then we identify what is it going to do, what is its functionality. So this is something we try to do top-down, even from the vehicle, item, system, and in the software. We can go even until the software units, each of the software units, and we try to identify its functionality, what it has to do according to the requirement. Once we are done with that, the third step, which is also a very important step, which is the failure net, which is also a bottom-up approach, which means in the second step, we identified what this particular, let's say, software component has to do, what is its functionality. However, in the third step, we are proactively trying to anticipate what can go wrong in this functionality. If at all it has to function in this way, what can go wrong in this? Yeah, what could be the failure? So this is something we are trying to identify as a part of the failure net. This is also, as I told in the beginning of the session, that we are proactively trying to anticipate what could be the failures, and once we identify the failures or the potential failures, we will try to identify or try to define the safety measure to prevent it if that occurs. The fourth step is derive safety requirements. For example, if at all, let's say we are doing FMEA in the system level, then I will derive technical safety requirements at the end of the FMEA in the system level. If at all I'm doing the FMEA in the software level, then I derive software safety requirements at the end of the FMEA. So it depends on which level you are trying to do. So once you identify the failures, now I know, hey, this could go wrong in this functionality. Now I try to define or write down the safety requirements which will kick in when such failures will occur in that functionality. So in this way, all in all, we are also trying to go back a bit into the very definition of the functional safety, where safety analysis method will also help us to correlate with the definition of the functional safety, which says that absence of unreasonable risk, which means when it comes to the functional safety, we cannot make a product 100% fault free, which is not possible, which is also not the intention. Rather, we try to anticipate what can go wrong, and we already have a safety mechanism in place when such things happen, so that the risk associated with this kind of a failures are kept in control or minimized.
So the last part of today's session is the how do we do FTA, and Phalgun is going to talk about how do we do FTA. Phalgun, off you go.
Thank you, Hassan. So here we have listed 4 different steps that are involved in FTA. This is the deductive way of performing safety analysis. So the first step here is to identify the undesired event. So we identify the undesired event. There can be more than one event. So for each of those events, we create different fault trees. Then we deduce all the different causes that leads to this undesired event from the below level. Like for example, if there is an undesired event at the vehicle level, at the system level, what are the different systems that will lead to this undesired event? That is what we are trying to do in our second step. Third step is once we have all the list of all the undesired events and all the causes that leads to these undesired event, we create a fault tree. Like there is a vehicle, there is a system, there is a subsystem, there is software, there is unit. So we create the complete fault tree. In this fault tree, this is where we add in different logical operations, which are, if it can be an AND event or an OR event, well, like two failures, two causes combined to give you the undesired event, or one of those two causes will lead to the undesired event. So this is what we are going to do in the construction of fault tree. And finally, once we have the complete fault tree analysis, what we'll do is we'll try to control these hazards, whether if we can somehow reduce the occurrence of these undesired events by putting in some safety measure. So this is the main outcome of this FTA.
One general question to both of you is, can there ever be a case where you have a bit of a conflict between the FMEA you did and the FTA you did, or is it only theoretical?
From my understanding, whatever FMEA we do, the outcome would be the safety requirements, and it is on top of FMEA that you create more and more protection so that you reduce the occurrence of the failure.
So there is no contradiction. However, you can discover new avenues which you didn't cover in the other FMEA analysis.
Exactly. So maybe to give an example, FMEA will give you a safety requirement saying that ensure that you perform plausibility check for all inputs. But FTA will give you what are the two different components which will lead to this. So both the plausibility checks that you need to do, you will get to know on what all components or what all units you have to do.
All right. So if you have questions or comments regarding FMEA, FTA, or safety analysis in general, please feel free to write in the comment section. Thank you again so much for watching. I really want you to hit the like button because this will help us spiking up the YouTube algorithm. And if you have gotten value from us, please hit the like button. And we're looking forward to see you in the next episode.